Hello everyone. In this video, we are going to talk about the abstract data type list and how to implement it using arrays. We have explained about the abstract data type list. It is going to be a collection of data that we store the data in ordered manner, in a sequence way, in a linear order. And we are going to give access to the data in a zero-based index way. So we should be able to add an item to the list at any arbitrary index at the beginning of the list, at the end of the list, or at any other position. We should be able to count how many items we have in the list. And these are all the specifications for the list. Okay, we have discussed that how different is the list, from an array. Okay, this is the list of specifications, the list of operations that we need to implement. Add a value. So if you don't specify the index, so by default it's going to add the item at the end of the list. If you give the index, it will add the item at that specific index. So basically it needs to shift the items and add the item at the value at that specific index that you want. Clear all the items index of checking what is the index of a value, get access to the specific index, remove a specific index, change a specific index to a different value, size, contents, and many more methods that you can actually define. It is important to know that actually list has been actually defined in Java collection API. You already have actually recognized that how important this abstract data type is. And of course, we have list in Java collection API. And there are two different implementations for that, just like these two different implementations that we are going to discuss here. The first one that we are going to talk about is going to be implementing a list using an array. So the implementation of a list using an array in Java is going to be called ArrayList. I am almost sure that if you have been coding in Java for actually quite some time, I'm sure that you have already used ArrayList. I have actually listed, written some example here for you that shows how to use an array list. All of those methods, a specification that we have defined here, you can see that they have actually defined for the array list from Java. Like here we have created an array list which is of type string. I'm going to talk about the generic implementation, but basically what here is telling me is that this line we will create a list, an empty list, which is going to keep a list of items, which all of them are going to be of type string. So when you put this a type between the less than or greater than this two symbols, it's going to say that the elements, the type of elements that you store in array list is going to be of type string. And so names.add, if you actually print the names after this line, you will see that the list is going to just contain the name Ajit. And then add Harry. Harry will be added at the end of the list by default. Chaitanya will be added at the end of the list. Steve will be added at the end of the list. And so on. So if you actually print the size, how many items you have already added, 5. So the size is going to tell you 5 elements has been added. I would recommend you, if you haven't worked with ArrayList, you just try this example on Eclipse and basically see that how you can work with ArrayList. And just as a recommendation for you, whenever you are using an array, not in this course, of course, because we are going to learn about the basics here, but in general, in other courses, when you are actually or anywhere, not in this course only, that whenever you think that you might need an array, you'd better use an array list. It just makes the life much easier for you, because you don't need to take care of the size of the array. Just be careful that the items, you know how many elements you have stored and so on. So I'm sure that you have already noticed the differences between a list and an array, and it's going to be much easier to work with an array list instead of a list. Instead of an array. Okay, so now we are going to look at the implementations of a list ADT. Here in this course, I don't want to just give you the list of data structures, good data structures that you can use. I wanted to show you how we can implement them as well. So the very first implementation that we are going to discuss is going to be array-based implementation. Of course, when you are implementing a data structure which is going to store the items in a linear order and give you access to the items in a indexed way, in a zero-based index way, the very first option that comes to mind to store the data as a data structure, to store the data, is going to be an array, right? Because array basically gives you all of these. It allows you to store the items in a linear order and allows you to store them in a zero-based index, and not only that, accessing to the items to each index in the array is going to be constant. This is very important for us, that access to, for example, you wanted to access to index 5, it's going to be constant in an array. So array is a natural choice for us. There are good things about the array. So the whole data fields that we need in our implementation is going to be an array. You need to create an array. Let's just call it items. And you also need to take care of how many items you have already stored in the list, right? So I need another variable, let's call it num items, that's going to tell me how many items have been stored in the list so far. So for example, if num item is k, it's telling me that so far k items has been stored in this list. So when you think about the array, this k also tells you that the last index that has been occupied is going to be index whatever is num items. For example, if num item is k minus 1 is going to be the last index that has been occupied. So remember, for example, if I'm going to implement the method add, that's adding to the end of the list, you by default know that the next index that you have to actually put the item is going to be index k, and you put the item here. So it's basically makes some part of the implementation very easy. But now let's actually look at, so far we have decided that what is going to be the main data structure, that's going to be an array, and what are going to be the data fields that we need for designing this class. We are going to design a class, right, for the list, the array-based list. So I need an integer variable, I'm calling it num items, that keeps track of how many items have been stored in the list, and an array that keeps track of all the items that I have stored. So this is going to be a kind of the very first implementation that I have started with. Here you can see that I have an array. I am calling it items. I have a variable of type integer, num items. So these are the main two data fields that I have. And I have also actually defined a static variable max list because when you are actually using an array anywhere, if you are actually creating an array in your class, and this is going to be the main data structure for you, you need to know that what is going to be the size of the array, right? That max list is going to tell me that, for example, I have defined it as a static, and I'm telling that I've initialized it with 50. So in the constructor, the constructor method, I will actually take some space for items, right? So the maxlist tells me that what is going to be the maximum size of the array, basically. So just 3 data fields, which this one is not going to be really a data field. These 2 are the main ones. So far you have already noticed that I have defined items of type integer. I just wanted to make the very first implementation simple for you to follow. But this implementation is not going to be our final implementation. You can see that I have written a couple of actually methods here. Not all of them are complete. They are not complete basically, but you can find the complete implementation in the source code that I have posted on Blackboard. So on Blackboard, I have posted 2 source codes, one for array-based list and the other one for singly linked list that we are going to talk about it later. So you can open the array-based list, and there are 2 packages, 2 versions of the implementation. So open the first version, v0, okay? Inside that, there are 2 files. One, the array-based list, basically the whole class that I have created. Here I have actually initialized it with 5 to make it actually small to probably show you that how we can increase the size of the array and so on. It doesn't really matter which size you are initializing this one with. Items, number of items, this is the constructor. So if I wanted to actually show you a couple of these methods very quickly, is empty, for example, the method is empty in any collection that you define is going to be a boolean. Usually we define it as a boolean method that returns true if the collection is empty, basically. So for example, if the list is empty, you return true. If it is false, you return if it is not empty, you return false. So here, to make sure that the list is empty or not, I just need to compare num items to 0. If it is 0, so it returns true. If it is not 0, if it is whatever greater than 0, it will return false, which means that it is not empty. Size, we just returns how many items have been stored in the list, so I need to just return num items. So I just forgot to tell you to mention that in the constructor, after we actually take some space for the item, we also initialize num items to 0, because basically when you create a list, the list is supposed to be empty, right? So num items, then how many items you have stored in the list is going to be 0. Okay, so let me actually see. In the main method, there is another actually here you can see that I have written my main method in the class test. So whenever you write down your code, if you are actually doing whatever, always add a class test and put your main method inside the class test. And be careful, inside this method main, we are just testing. So you can see that I didn't write down any part of the main class array based list here. I just write down some test code here to just test my code for me. So here it's just testing that creating a list for me, an object of the array based list that I have created, and I have actually implemented all the methods add. Let me actually show you the method add here. It's not the complete method. No, not this one. Okay. The method add. Okay, let's actually forget about the implementation so far. Let me just actually show you that how it works. And then I will actually come back to the implementations later. You can see that the method add here, it's supposed to actually insert, if I'm actually telling the list to insert 7 at index 0, insert 6 at index 0. So after this line, if you print the list, it should be 6, 7. And then inserting 5 at index 2, and then inserting 4 at index 1, then add 3. So basically at this point 3 should be added at the end of the list, or then actually insert 2 at index 0. You can play with it and just write whatever you want here. Just be careful when you are actually inserting at some specific index. That index is supposed to be a valid index.